It's 1.4, talking about relationships and patterns. All right, usually you're gonna get some type of table here, like this. It's got term numbers, and it's got a term on it. Usually it says something like number of squares, number of triangles, number of cubes, number of cups, like something like that, all right? Now, how it goes down is for term 1, figure 1, whatever it is, it has 3, in this case, squares. So that's three squares. So for figure 1, which is this, that's 3 squares. Figure 2 is gonna have 6 squares. Figure 3 has 9 squares. Figure 4 has 12 squares. I didn't draw it because that's too many squares. And figure 5 has 15. I'm lazy, I didn't draw it. What's the whole point of this, Mr. Ram? Well, let me tell you. The whole point of this is to create an algebraic expression from this table. Now I'm gonna get rid of this drawing because we're not grade 4 anymore and we don't need pictures, all right? We have this. We ask ourselves, what is the relationship going down? What's the relationship over here? So here we can see it goes up by 3 each time, right? 3 plus 3. Over here it's going up by 1 every time. Now if you don't know that, you're in serious trouble. Go back to grade 4. For those of you who are right, let's keep it moving. The next step is to figure out an algebraic expression. So it's usually like 2 times some random number. I'm going to use n as a symbol representation, and since it's an expression, we don't put an equal sign. It expresses the pattern at play. The pattern is, now I figured out the pattern of this side, the term pattern, and I found out the term number pattern, which is +1 on this side, and this one's +3. But what is the relationship between this side to this side, right? What is happening here to get from, sometimes they call it input to output, right? So how do we get from this input to this output, this input to output? And it has to be the same every single time. Usually it's multiplication or division. In this case, look at our 1 to 3. It's getting bigger, so we're probably not going to divide, we're probably going to multiply, right? 2 to 6, 3 to 9. It's getting bigger each time. So that means, in my head, I'm thinking it's got to be something times something. So let's keep going. Let's try 1 times 2, okay? When in doubt, just try every single one. 1 times 2 is, no one saw that, right? Is 2. Is that what we're looking for? Absolutely not. Go home, you're wrong. Next up is 1 times 3, right? After 2 is 3. Try that. 1 times 3 is 3. Yeah, you're right. So it checks out for term number 1. Let's try term number 2, okay? For 2 times 3, it gives us 6. Is that what we're looking for? Absolutely. And just to make sure, we're going to do the next one, which is term number 3. Times it by 3. And does it give us 9? It absolutely does. So we're cool. We figured out the pattern is that it's timesing 3 each time. Cool. You know that from grade 6. Now, how do we write that as an algebraic expression? Easy. We take our number, okay, 3, we're timesing stuff, and then what does it mean to put 3 times n? 3 times a random term number. Well, we can simplify that and write 3n. That's it. Look at that. 2 things I only wrote, and I get 100% on this question. Let's do a harder one. All right, harder one. Here we go. We have a word problem. We love these guys. Legit problem, though. Mr. Ram, that's me. I'm trying to plan a class party. Okay, the cost of renting the lounge is about $500 to start up. Okay, the cost per food per kid is going to be $30. Okay, we need to write an algebraic expression so I can figure out the actual cost of what's going down. So let's start off with highlighting some important information. Mr. Ram, of course, we're going to highlight that. Just kidding. I'm doing a pause. Okay, so cost. Here's one cost of renting a lounge is $500. So that's one cost. Now, do I do that cost like multiple times? No, I just rent it once for the day, okay? So it's a one-time cost. There's another cost. Cost of food is $30, but it's per person. So is it a $30 one-time fee? No, 30 times as many people as I bring. In this case, is students. And I have 28 students. So let's figure this out. The geniuses in the front row already know, right? We have a cost here of 500, okay? We also have another cost, so we're going to add 2 costs together, which is $30. But is that correct? No, because it's 30 times however many people I bring in per person, right? So how do I say that? Times people, right? Does that look like a good expression? No. There's too many symbols going on, too many letters, too many whatevers. Let's simplify. As mathematicians, we hate wasting our time. Let's go quick. So I got an initial cost of 500 plus 30, right, times number of people. I'm going to use P. P for people. Or you can do S. It doesn't matter. Use whatever the heck you want as long as it's clear. S for students. That is our algebraic expression. Now let's use it. Check it out. It says, now use your equation essentially to find out if n equals 20, right? Because we said n or p or s, whatever it was the amount of people that we're bringing per person. Right? So now it says how much money is it going to cost to bring 20 kids. Easy, right? Rewrite the equation here, and then instead of n, I'm going to put a bracket. I'm going to put in whatever number we want to put in. That's what n represents. Any random number of people that we're bringing in. No matter what number we bring in, this algebraic expression will work. It shows the pattern. That's why this is cool. So in this case, we're going to do 20. So when you see this, a number beside a bracketed number, you know that means multiply. So we're going to multiply here. It's going to cost us exactly $1,100, $1,100. So we just found out, using an algebraic expression really quick, of cost for renting and for food of a cool field trip that Mr. Ram planning out.